Welcome to the mathematics video class. Today we are going to learn about the first chapter of your class 8, that is rational numbers. Before we begin, let us have a look at the number systems that we have studied in our previous classes. The first type of number systems is natural numbers. So what are natural numbers? All the counting numbers are called natural numbers. They are denoted by capital N. As we all know, the smallest natural number is 1 and the largest natural number is undefined. Next comes the set of whole numbers. So, what are whole numbers? The set of natural numbers together with 0 forms the set of whole numbers. They are denoted by capital W. The smallest whole number is 0 and the largest whole number is undefined. After the set of natural numbers and whole numbers, next we have integers. What are integers? Integers are the set of positive and the negative numbers including 0. The set of integers are represented either by Z or I. Both the smallest and the largest integer are undefined. But the largest negative integer is -1, whereas the smallest positive integer is +1. Dear Slaters, do you think that we have only 3 number systems then? No. To understand the next number system, let us take a look at the following fundamental mathematical operations. Let us consider two values. A is equals to 1 and B is equals to 2. Now, let us perform the fundamental mathematical operations on them. Let us take a look at the result and decide the results falls into which category of the number system. A plus B. A plus B is equals to 1 plus 2, that is equals to 3. We know that 3 is a natural number. A minus B. 1 minus 2 is equals to -1. We know that -1 is an integer. A into B. 1 into 2, that is equals to 2. Again, 2 is a natural number. Then, what about A divided by B? Which is equals to 1 divided by 2. 1 divided by 2 is written as 1 by 2. That is the fractional form. 1 by 2 comes under which category of the number system? Today, to understand this, we are going to learn a new set of number system called as rational numbers. Take a look at the definition of rational numbers. The numbers which are in the form of P by Q, where P and Q belongs to the set of integers and Q is not equal to 0, are called rational numbers. The set of rational numbers is denoted by capital Q. That is because Rational numbers are also known to be the quotient numbers. Now do you understand, children, why 1 by 2 is called as a rational number? 1 by 2 is in the form of P by Q, where 1 and 2 both are integers and the denominator Q, that is 2, is not equal to 0. So, all the natural numbers, whole numbers and integers are rational numbers, as they can be expressed in the form of P by Q. For an example, if you consider the natural number 2, the natural number 2 can be written as 2 by 1. If you consider an integer minus 5, the integer minus 5 can be written as minus 5 by 1. What do you mean by standard form of rational numbers? A rational number P by Q is said to be in its standard form if it is written in its simplest form, which means P and Q both have to be coprimes. Do you remember what are coprimes? Yes, which means their highest common factor is 1. Also note that the rational number P by minus Q is same as minus P by Q is same as minus P by Q. It is now time to understand the properties of rational numbers. The first property is the closure property. Before you take a look at the closure property, remember, my dear slaters, A star B denotes the fundamental operations performed on A and B. So now, if A comma B are two rational numbers, then A star B is also a rational number. Let us take some examples and cross-check if this is true for all the four fundamental operations. Under addition, considering a rational number A is equals to 2 by 3 and B is equals to 4 by 5. What is the result when we add A and B? 2 by 3 plus 4 by 5 results into 22 by 15. Is 22 by 15 a rational number? Yes. Which means rational numbers are closed under addition. That is, for all A comma B belongs to Q, A plus B also belongs to Q. Now, let us cross-check if rational numbers are closed under subtraction. Considering two rational numbers, A is equals to 2 by 3 and B is equals to 1 by 5, let us perform the subtraction operator on it. That is, A minus B is equals to 2 by 3 minus 1 by 5, which results into 7 by 15. So, is 7 by 15 a rational number? Yes. 7 by 15 is also a rational number, which means rational numbers are closed under subtraction. For all a comma b belongs to Q, a minus b also belongs to Q. Now, to cross-check if rational numbers are closed under multiplication, considering a is equals to 1 by 2 and b is equals to 3 by 4, perform the multiplication operator on the rational numbers. That is, a into b is equals to 1 by 2 into 3 by 4, which results into 3 by 8. As we all know that 3 by 8 is also a rational number, we can conclude that rational numbers are closed under multiplication too. That is, for all a comma b belongs to Q, a into b also belongs to Q. Before we cross-check if rational numbers are closed under division, let us understand the most important concept in maths, that is division by zero. If any number is divided by zero, then its result is undefined. As you all can see, a divided by 0 is undefined. What do you think, Slaters? Are rational numbers closed under division? Let's take an example and cross-check. If a is equals to 3 and b is equals to 0, then a divided by b is equals to 3 divided by 0. Is the result defined for 3 divided by 0? No. As we have previously seen that division by 0 is undefined, which means 3 divided by 0 is also undefined. Thus, rational numbers are not closed under division. For all a comma b belonging to rational numbers, a divided by b need not belong to rational numbers. So, rational numbers are closed under addition, subtraction, multiplication, but not under division. The second property of rational numbers is commutative property. Children, if the distance between 2 points A and B is 5 centimeters, then can I also say that the distance between the points B and A is also 5 centimeters? Yes. Commutative property is similar to this. Let us try to understand. If A and B are two rational numbers, then A star B is equals to B star A. That means we are going to cross-check if we add or subtract or multiply or divide the rational numbers in any order, then do we get the same result? Firstly, let us cross-check commutative property for addition. If we consider two rational numbers, a is equals to 2 by 3 and b is equals to 4 by 5, then a plus b is equals to 2 by 3 plus 4 by 5, which results into 22 by 15. Similarly, b plus a is equals to 4 by 5 plus 2 by 3, which also results into 22 by 15, which means a plus b is same as b plus a. Commutative property is true for addition of rational numbers. Now, let us cross-check if commutative property is true for subtraction of rational numbers. Considering two rational numbers, a is equals to 5 and b is equals to 2. We have a minus b is equals to 5 minus 2, that is equal to 3. Whereas b minus a is equals to 2 minus 5, which results into minus 3. As we all can notice that a minus b is not equal to b minus a, we cannot say that commutative property is true for the subtraction of rational numbers. Do you think that commutative property is true for multiplication of rational numbers? Let us cross-check. If we consider two rational numbers, a is equals to 5 and b is equals to 2, then a into b is equals to 5 into 2, that is 10, and b into a is equals to 2 into 5, that is also equals to 10. Which means a into b is same as b into a. From which we can conclude that commutative property is true for the multiplication of rational numbers. Similarly, let us cross-verify if commutative property is true for the division of rational numbers. Considering two rational numbers, a is equals to 3 and b is equals to 1. We have a divided by b is equals to 3 divided by 1, which is equals to 3, whereas b divided by a is equals to 1 divided by 3, which is equal to the fraction 1 by 3. We can clearly notice that a divided by b is not same as b divided by a. From which we can conclude that commutative property is not true under division of rational numbers. From this, we understand that rational numbers satisfy commutative property only under addition and multiplication. The third property of rational numbers is the associative property. Here, in associative property, we involve three values. Considering three values a, b, c, then a star b star c is equal to a star b star c. Slaters, as you all are aware that according to Bodmer's rule, we first solve the terms inside the bracket. So, keeping the same in mind, cross-verify if associative property holds true under addition, subtraction, multiplication and division of rational numbers. Once you cross-verify, you will be clearly able to conclude that associative property holds true only under addition and multiplication of rational numbers. Slaters, now it is time to learn about additive identity and multiplicative identity of rational numbers. So, what should be added to any rational number such that the result remains the same? Yes, it is 0, which means 0 is called as the additive identity of rational numbers. If A belongs to Q, then A plus 0 is equals to 0 plus A is equals to A. Now, which number should be multiplied to any rational number to get the same value as a result? Yes, it is 1. If 1 is multiplied to any rational number, then the product remains the same. Hence, 1 is called as the multiplicative identity of rational numbers. That is, if A belongs to Q, then A into 1 is equals to 1 into A is equals to A. Next comes additive inverse and multiplicative inverse. So, what should be added to a rational number A to get the sum as 0? Yes. If A is a rational number, then we need to add minus A, that is the negative of the same rational number, to get the sum as 0. Here, minus A or the negative of the rational number A is said to be its additive inverse. If 2 by 3 is a rational number, then minus 2 by 3 is said to be its additive inverse, or vice versa. If minus 2 by 3 is a rational number, then 2 by 3 is said to be its additive inverse. Now, what should be multiplied to a rational number such that its product is equals to 1? Yes. If A is a rational number, then it should be multiplied with 1 by A such that their product is equals to 1. Here, 1 by A is said to be the multiplicative inverse of the rational number A. Isn't it nothing but the reciprocal of the rational number? Yes. Multiplicative inverse is nothing but the reciprocal of the rational number. For example, the reciprocal of 4 is 1 by 4. That is, 4 into 1 by 4 results into 1. Henceforth, 1 by 4 can also be called as the multiplicative inverse of 4. Here comes the last property of rational numbers, that is distributive property. If A, B and C are 3 rational numbers, then A into B plus C is same as A into B plus A into C. For an example, consider A is equals to 3, B is equals to 4 and C is equals to 5. 3 into 4 plus 5 is nothing but 3 into 9, that is 27. 3 into 4 plus 3 into 5 is nothing but 12 plus 15, that is again equal to 27. So, we can clearly say that rational numbers are distributive under multiplication over addition.